Hello, welcome back. We're going to continue our discussion about logs, and we are going to start solving logs that require a little bit more steps. So in several cases, the log won't be isolated on one side of an operation symbol, such as equal to, greater than, less than. So we'll have to isolate it before we exponentiate it. And then other types of logs that we'll be solving is where we have to condense first in order to either use an exponentiation or to use the equality or inequality property of logs. All right, so let's just jump right in here and let's solve the log base 3 of the input 6 minus 3x minus 3. Notice that this minus 3 here is not part of the input, okay? It is separate from the input. The input is what's in the parentheses. So we have to isolate that log first. So we would have log base 3 of the input 6 minus 3x is equal to positive 3. Positive 3. I just added 3 to both sides. Now I'm going to exponentiate. My input, 6 minus 3x, has to be equal to my base, which is 3, raised to the third power. And now I'm going to solve. So I get 6 minus 3x is equal to 27. Negative 3x is equal to, I'm going to subtract 6 from both sides, 21. So x is equal to negative 7. All right? So I'm saying that negative 7 is the solution to that equation using that log. So if I check it, I would have log base 3 of 6 minus, let me change that real quick. 3 times negative 7 minus 3 equals 0. So let's clean this up, and I get log base 3 of the number 27, and then minus 3 is equal to 0. So what value does log base 3 of the input 27 have? Well, that's going to be 3. So 3 minus 3 equals 0, and it checks. Okay? This next problem is going to require that we condense before we solve, okay? So notice that I have like a bunch of logs. I have 2 on the left, 1 on the right. If I could condense that left to a single log, then, seeing as my bases are the same, I could set my inputs equal to each other using the equality property of logs. So let's do that. So this is log base 2 of x to the 4th over 5. So I moved this to the power, and then this is minus, so I move my input to the denominator. And now I can leave this side as it is. Okay. Now I can use the equality property of logs, which says that x to the 4th over 5 has to equal 125. Now I'm going to solve for x to the 4th, and that's going to be 625. I'm going to multiply 5 on both sides, okay? And then here, I'll write that in too. That cancels, all right, and that becomes 625. Now I'm going to take the 4th root of x to the 4th, and what I do to one side, I have to do to the other. And so this simplifies into plus or minus 5. Okay, so what we want to do is we have to be careful about plugging in negatives into our original. So in this case, my positive 5 works fine. All right, I'm going to focus on the negative 5. I cannot plug in a negative 5 into an input. All right, So -5 would not be a solution. So my only solution would be +5. All right. Now I'm going to solve a log where I have to do some kind of condensing on both sides of my equation before I can use the property of equality. So this becomes log base 7 of x squared equals log base 7. I'm going to multiply these two together. This is my product property. So I'm going to multiply these two and I get 81. Now my bases are the same, so I set my inputs equal to each other. So when I solve that by taking the square root of both sides, I get x is equal to plus or minus 9. And when I check those two solutions, my only solution that works is x equals 9. It's not to say that you can never have a negative value going into your input. You just have to check to make sure that it doesn't create a negative input. All right. You could be adding or subtracting or multiplying by an input that it would be okay. So if you notice on our first one, we got x equals -7 and it worked just fine. Okay. All right, here's our next log equation. So what we're going to do here, there's lots of steps. I'm going to do 2 in 1. I'm going to condense and isolate at the same time. So that requires me to add 4 to both sides over here. And then when I condense this log base 6, these two inputs will be multiplied together. Whoops. So that's going to equal 2. Now I'm going to exponentiate, which says that my input, x times x minus 9, has to equal my base raised to my exponent. Okay, so that gives me x times x minus 9 equals 36. So now I'm going to distribute. So I get x squared minus 9x. Sorry, minus 18x. Nope. Minus 9x. Minus 36 is equal to 0. Now I'm going to factor that to solve. If you'd rather use the quadratic formula, feel free. This will be x squared minus 12x plus 3x minus 36 is equal to 0. And I'm going to factor, so I get x minus 12, and then I'm going to factor out a 3, and I get x minus 12. And now I get my two factors are x plus 3 and x minus 12 equals 0. And when I set those equal to 0, then this one becomes -3 and this one becomes positive 12. Now we have to check. Notice that if I plug in a -3 up here, this is going to produce a negative input. I can't have that, so that one doesn't work. And then if I check 12, that's positive. 12 minus 9 is 3, that's positive, so that one is the solution. So x equals 12 is the solution. All right, hopefully you've been successful with the video questions. If not, write down the ones that you missed so that you can ask me about them, and I will see you tomorrow. Thank you so much for listening.